Hey y'all, we're going to keep this accessory digestive organ train a-rolling, this time with the pancreas. The pancreas is a mixed gland. It is both exocrine and endocrine, and we'll investigate both parts here in just a minute. The pancreas is located kind of posterior to the stomach, and the exocrine portion is going to secrete via a pair of ducts into the duodenum or duodenum of the small intestine. So we can see that here up at the top. And if we look a little closer histologically, we can see the mixed nature of the gland. We have acini surrounding ducts, so we have a branched acinar type gland going on here, and the acinar excretory portion is going to be secreting digestive enzymes, and I'll tell you which ones here in just a minute. And then you're also going to see, if we can think of the pancreas as being kind of like a sea of exocrine tissue, you're going to see little islands of endocrine tissue throughout, currently referred to as pancreatic islets, but you still might hear them referred to by their older eponymous name, the islets of Langerhans. So when you hear some fossil like me talk about the islands of Langerhans, we're actually talking about the pancreatic islets. We just learned an older, no longer preferred name for them. So let's look at actual histology here. This is kind of a low mag shot of the pancreas, and we can see some notable features. First, this conspicuous duct running, what would be a good color here? Maybe yellow. This conspicuous duct, oh yeah, that shows up nice. Running through our CO exocrine tissue. So here's a duct going on here. We can see numerous capillaries. Note right in here, those little red discs that I just covered up with my marker. Here's a better one, a little arterial, or a little venule, sorry. There's a little arterial, yeah. So we've got plenty of vasculature in here, and all of this stuff out in here, this darker stained stuff, is exocrine tissue. All of this mess out here. We're actually going to zoom in on two structures as we move through here. So we're going to zoom in right here where we can see a single exocrine acinus, and we're also going to zoom in over here where we see one of those pancreatic islets. So this is an exocrine acinus. It's supposed to be an A. There we go. And then over here we have an endocrine islet. So let's zoom in first on the acinus and look at the exocrine portion of the pancreas a little more closely. Here we can see that single acinus, so right in here, surrounding a duct. So here's the duct here, and like that. So its components are going to be secreted out into here, and this is going to secrete digestive enzymes or bicarbonate or a mixture of the two. When chyme first enters the duodenum from the stomach, it's highly acidic, and so these pancreatic cells are going to primarily produce bicarbonate, a base, to neutralize the acid. Then once the acids have been neutralized, these acini will switch over to secreting enzyme-rich, what we call enzyme-rich pancreatic juice. And that enzyme-rich pancreatic juice will contain proteases, lipases, nucleases, and amylases that will break down the macromolecules in the food into its base components so that it can eventually be absorbed later on in the jejunum. So it's the exocrine pancreas. There's not a whole lot to it. You guys have seen secretory epithelia before. I do think it's kind of cool. You can see this capillary back here. And it's not for nothing. I just think it's really neat. You got the red blood cells lined up 2 by 2 over here, so it's a pretty narrow capillary. You're looking at something that's about 15 micrometers wide right there. Well, let's look at the endocrine pancreas then and see how this is different. Here we can clearly see these columnar secretory cells around their central duct. When we look at a pancreatic islet, we of course see no such thing because endocrine glands, which is what the pancreatic islets are, don't have ducts. Instead, notice, so here I'll just outline the whole thing. They're pretty easy to pick out because they tend to be lighter colored in staining than the exocrine cells. But also inside of here, look here, there's a little capillary. There's a little capillary right in here. I feel like Bob Ross, there's a happy little capillary. And it makes sense that we're going to see a lot of capillaries in here because this is endocrine tissue. And endocrine glands secrete their products where? Directly into the bloodstream. So out here we can see the sea of exocrine tissue surrounding our pancreatic islet that I've outlined here in yellow. And I found some cool pictures on Wikimedia Commons that are of stained pancreatic islets. And in this one, and I'm going to have to switch pen colors since I got a white background, switch to black. Up here, we have stained the alpha cells. We find two kinds of cells in the pancreatic islets, and alpha cells produce a hormone called glucagon, which raises your blood sugar. So during times of fasting, the alpha cells will be stimulated to release glucagon, which will then tell your liver, hey, take some of that glycogen you're storing and break it down into glucose. We need to raise the blood sugar. The lower image shows pancreatic beta cells. Beta cells produce the hormone insulin. When you're not fasted, for example, after a meal and your blood sugar starts to rise, the insulin from these beta cells will tell your liver, hey, take the sugar, the extra sugar out of the blood and store it as glycogen. And we'll talk a little bit more about the endocrine pancreas later on. But really, that's it for the pancreas. You've got an exocrine portion that makes bicarbonate or digestive enzymes, and an endocrine portion that makes the hormones glucagon and insulin. Well, that's it for now. Hope you had fun. Study hard. We'll see you later.